What up, mathletes? Whoop, whoop. All right, let's do this. Let me get stuff in place here. So our learning target today is up above. I will use inductive reasoning, make conjectures, and give counterexamples. See your warm-up right here. Take a minute, look at it, and do it. Remember, as always, I'm going to kind of trudge forward in between everything. Pause if you want to, especially when we get to paper, rock, scissors. We'll get to that. It'll be awesome. All right, let's roll. So we see right here in the warm-up, 3 squared equals 9, 5 squared equals 25, 7 squared equals 49, 17 squared equals 9. I'm squaring a bunch of odd numbers, and every time the result is an odd number. So what's a conjecture? What's something we can make? What is just a conclusion we can make from this? We can conclude that the square of an odd number is probably going to be an odd number, because it is on every one of these examples. Now, are we able to square every odd number on the planet? No, there's an infinite amount of odd numbers. We're just making a guess based upon some examples here. How about 4 squared equals 16, 8 squared equals 64, 12 squared equals 144, and 20 squared equals 400? In each of these cases, we're squaring an even number and getting an even answer. So we're going to say the square of an even number. We're going to conclude, maybe wrong, but just based upon my information, that the square of an even number is an even number. Okay. Number 3, 2 plus 5 equals 7. 15 plus 4 equals 19. It looks like we're adding an odd and an even number. Even and odd number, right? Yep, even and odd number. So 22 plus 13 is 35. Notice the result each time is an odd number. So the sum of an even and an odd number is an odd number. All right, we're just trying to play odd or even. Okay, let's go ahead and go to our vocab today. I'm just going to splash it up on the screen for a minute there for you to pause. We have inductive reasoning, which is what we were doing just then. It's the process of reaching a conclusion based upon a pattern of examples. And so inductively, we looked at those examples, we reasoned out a conjecture, and a conjecture was an educated guess based upon known information and specific examples. Now, could be that sometimes you're given a conjecture and you can think of a counterexample, which is an example that contradicts the conjecture, showing that the conjecture is not always true. Okay. Again, pause this, but we're going to move on. Let me just get this loaded up. It'll be ready for when we get back. Oh. Okay, so you should have all that down. Now, I want to play paper, rock, scissors with you, so you should pause in between each one. Are you ready? Indicate what Mr. Tim will choose and your win-loss record. Are you ready? Let's do this. Ready? Rock, paper, scissors, shoot. I chose rock. Did I beat you? You can write down that I chose rock. So this is going to be Mr. Tim. And then down here, did I win or lose? So you indicate that, okay? All right, you ready? Let's do it again. Rock, paper, scissors, shoot. How'd I do this time? I chose rock again. Did I win or lose? Write that down. One more time. Rock, paper, scissors, shoot. Oh, I chose rock again. Did I win or lose? How am I doing? If we play again, I believe Mr. Tim, based upon this information, what do you think I'll choose? Clearly, I'll choose rock. Right? That's what it sounds like. So let's play again. Are you ready for this? Rock, paper, scissors, shoot! I did rock again. You were right. Did I win or lose? Again, indicate that. We made a conjecture based upon the information we saw, and it turned out to be true. Could have been changed, but it wasn't. All right. So let's talk about this. Look at the following appointment times: 8:30 a.m., 9:15 a.m., 10 a.m., 10:45 a.m. Before we make a conjecture, first thing we want to do is we want to look for a pattern. Is there a pattern we're seeing here? Let's see, 8:30 to 9:15 a.m., that's 45 minutes. 9:15 to 10, that's another 45 minutes. 10 to 10:45, that's another 45 minutes. So what do we see? We see that there's 45 minutes in between each appointment. Once you find a pattern, step 2 is make a conjecture. So we're going to make an educated guess. And what is the conjecture I'm going to make today? I'm going to say appointments are made every 45 minutes. The next in the pattern would be 11:30 a.m., 12:15 p.m., and if we did one more, we'd have 1 p.m. Okay? Again, pauses needed. So let's apply this process down here. Look at this pattern. We go from 1 square to 4 squares. If you count that, 1, 2, 3, 4 by 1, 2, 3, 4, 16 squares. So we have 1 here, 4 here, 16 here. Do you see a pattern here? Yeah. Each one is times 4. And it says, what will the next figure look like? Well, it would be times 4. And what's 4 times 16? That'd be 64 squares. And how do I get that? Well, I'll show you. We're actually going to kind of go through this process. We'll cut it in half. Then we'll cut it in half again. And now we're going to be at this third figure. And then we're going to cut each one of these in half again. 1, 2, 3, 4. That's the best way I know to do it. And then same this way. 2, 3, 4. Let's look what we have here. We have a 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. So that has 64 in it, and that is what we would have. 64, because it's times 4 each time. Okay, again, temperature is 65 degrees, 58 degrees, 51 degrees. Let's look for a pattern. So that's what? -7. -7. So each temperature is 7 degrees less than the next temperature in the sequence. All right, nothing too bad. Here's one right here. I want you to take a minute, make a conjecture about the product of two odd numbers. Okay, so how do I look for a pattern? Well, how about I start putting some examples down, right? So I'll create my own examples. So if you want to find a pattern and you're not given anything to deal with, I can multiply. Product means multiply, right? So I'm going to multiply two odd numbers, any two odd numbers. What two odd numbers am I going to pick? Let's do 3 times 5. That's 15. How about 7 times 5? That equals 35. How about, let's do 9 times 7. That equals 63. Or we could even do 3 times 25. That equals 75. So I think we're seeing a pattern here. The product of two odd numbers is coming out with an odd number every time. So our conjecture we're going to make is product of two odd numbers, remember that's a symbol for numbers, is an odd number. Oh, awesome. So moving on, it's right here, it says the shaded quadrilateral. Our choices: moves 2 sections counterclockwise between figures, moves 2 sections clockwise between figures, moves 3 sections counterclockwise between figures, moves 1 section clockwise between figures. Let's see what it's doing. First of all, it's going from here, and then it's going to go up, and it's going to go to the right. So it looks like it's moving clockwise. So first of all, that's how a clock goes, right? So we're going to cross out the counterclockwise choices. That's not one, and that's not one. And then how many does it move? Let's see, it goes, it started here and it goes 1, 2. Okay, so it started here and went 1, 2. So that means it's moving 2 sections clockwise, not 1. And if I were to draw the next example, if it started here, it'd go 1, 2, so I'd shade in this region, which we're told to do, color the missing region. Awesome. Not too bad here, I don't think. Now take a minute, See if you can look at a pattern in the data and figure out. It says the owner of an ice cream shop collected data on the total sales for the first 5 months that the shop was open. Predict the total sales in the 6th month. Okay, go ahead and do that. Take a minute, pause me. All right. Well, let's see. 500 to 700 was $200, right? 700 to 950 is $250. 950 to 1250 is $300. Are we seeing a pattern now? 1250 to 1600 is $350. It's growing by $50 more each month. So that means if I were to add 50 to 350, I would end up growing by 400, which would put me at 2,000. So the owner will make I can't see that all the way, $1,000 in the 6th month. Perfect. Okay. All right, I want to talk about conjectures here. Let's go ahead and look at our last slide today. You'll see this is the same thing that's on your paper, so we're just going to fill it in. It says, conjecture. If an item costs $2.49, then it is a carton of juice. Is that true? Not necessarily. What's a counterexample? Counterexamples are when we see a conjecture and we're like, no, we can prove that wrong. So counterexample, bread can cost $2.49. So counterexample, we're going to write down under counterexample, Mama's bread costs $2.49. Now, clearly we made that up, right? That's just a made-up brand. But you can think of anything. A toy car costs $2.49. Anything you see that costs $2.49 that is not orange juice would disprove this. So clearly there's other things with that price tag on it. How about this? The conjecture, if a flower is red right here, then it is a rose. Well, is that the only red flower out there? No. How about this one? It's a red tulip. So the counterexample could be a tulip is red. Or we could even say, how about this? A carnation is red. Or red carnations, right? Lots of flowers that are red you can put in there. So clearly we can prove that wrong. So you'll see I just put those in there. Now we're going to go down to this. Find counterexamples to show each of the following is false. If n is a real number, then negative n is a negative number. Okay, well, are there any numbers you can think of that if I took the opposite of them would not be negative? How about if n equals -5? Then negative n would equal negative 5. What's a negative make? A positive. There's a counterexample, and there's an infinite amount of counterexamples. Or looking over at this figure right here, if angle ABC is congruent to angle DBE, so if these are ABC is congruent to DBE, those are congruent angles, then angle ABC and angle DBE are vertical angles. Well, to be vertical, you have to be straight lines that are crossing, right? Those are vertical angles. However, do these look like straight lines crossing? Absolutely not. So what is our counterexample? Our counterexample is the very thing we're looking at. So in the figure, two things are going on. Angle ABC, and we're told right here, the figure shows us these are congruent. We've set those congruent. Is congruent to angle DBE. But they are not vertical angles. Okay? So this figure actually proves it. How about the next two? Why don't you try to read them, pause this, do it on your own, and then I'm going to go through them pretty quick. Ready, set, go. Just want to give you time to pause. All right, now I'm going to roll with it. If n is a real number, then n squared is greater than n. It seems like it makes sense. 2 squared is 4, 4 is greater than 2. 5 squared is 25, 25 is greater than 5. However, what if the numbers are between 0 and 1? So like 1/2. If n equals 1/2, then n squared equals 1/2 squared, which is 1/4. And guess what? A quarter is less than a half. Don't believe me? If you have half a dollar, you have 50 cents. If you have a quarter of a dollar, you have a quarter, 25 cents. So 1/4 is less than 1/2. There's your counterexample. If I were to use a decimal, if n equals 0.3, n squared would be 0.3 squared, which would be 0.3 times 0.3, or 0.09, right? You got to move that decimal over for each one. And 0.09 is less than 0.3, because that's like, I can put a 0 there. That's like saying 9 cents is less than 30 cents. See? Okay, let's look down here. If two angles are supplementary, then they are adjacent angles. I can prove that's not true. In one of your notes from the last section, you can prove that's not true. How do we know? Let's look at these two angles. To be adjacent, they have to share a common side. Let's call this 110 degrees. And this is going to be A, B, C. I'm going to draw this angle over here. And this is angle D, E, and F. And it's 70 degrees. Are they supplementary? Yeah, I know that because 110 degrees plus 70 degrees equals 180 degrees. That's supplementary. Are they adjacent? No. Why not? They don't share a common side. This would be your argument against that. So this is non-adjacent. Angles that are supplementary. Okay? All right, so today we've talked about using inductive reasoning, so looking at examples to find a pattern, and we use that to make a conjecture. But when we're given a conjecture, we don't just assume it's true. We try to search our brain, think, can we find a counterexample to disprove it? All right, with that said, peace out.